Let's take a look at another example here. First thing I see is that this is improper. In case you forgot what the definition of an improper rational function is, this is to the third power, this is to the second power. That's improper. So I'm going to just simply divide. So I will have x squared plus x minus 2. I'm going to divide it into x cubed minus x plus 3. This is kind of like grade school long division. How many times does x squared go into x cubed? What goes in x times? That gives me x cubed plus x squared minus 2x. Just like in grade school, I'm going to subtract it. That's going to be a 0. This is going to be a negative x squared. That's positive 2x minus x. This could be plus x. That didn't look too good. Let me fix that real quick. Plus 3. So now I'm going to have, well, gosh, how many times did x squared go into negative x squared? Well, that's minus 1 times. So that's a negative x squared minus x plus 2. And of course, once again, I'm going to subtract, so all these signs have changed. That's 0. This will be 2x. This is going to be a negative 2, so that would be 2x plus 1. So this is my remainder. And of course, we don't write it as a remainder. Remember grade school when you went r equals 2x plus 1? No. I'll show what we're going to do with it in just a second in case you forgot. So I can now say that this is the integral of x minus 1 plus 2x plus 1 over x squared plus x minus 2 dx. So here's my remainder. Is this thing divided by the original? Well, obviously, this is extremely easy to integrate, this piece right here. Well, let's go ahead and just do that. Just this piece alone, if I integrate it, it will be x squared over 2 minus x. So I need to keep track of this. That's like, I'm going to call it like part 1. This, well, there's a couple of things here. I could break this down by partial fractions again, because this denominator is actually the same as x plus 2 times x plus, x minus 1. And then work out the whole partial fraction thing, which will work out rather nicely. Or I could notice if I let u equal x squared plus x minus 2, then du equals 2x plus 1. That's exactly what I have. So I could finish this up in partial fractions, but I don't have to. Matter of fact, I'm going to take the easy way out, and I'm going to use the u substitution. So if I make that u substitution, then this piece becomes the integral of 1 over u du. That's pretty easy. That's just ln u, which is going to be ln absolute value of x squared plus x minus 2. So I'm going to call this like part 2. And if I put these parts together, what I get is my original integral of x cubed minus x plus 3 over x squared plus x minus 2 dx is equal to x squared over 2 minus x. This is a positive, so plus ln absolute value of x squared plus x minus 2. And I can't forget that constant of integration. Technically, I broke this up, so this should be like plus c1. This should be plus c2. Doesn't really matter. These all combine into one constant of integration.